welcome to my presentation on atoms, bonds and structures. Today I will be deducing the number of protons, neutrons and electrons in atoms or ions according to their atomic mass, number and charge. So first of all we take boron, a non-metal. The two numbers important for deducing protons, neutrons and electrons is the atomic number. The atomic number also tells us how many protons are in the nucleus, and then the bottom number as well that we'll need, the mass number, which shows the total number of protons and neutrons, its relative mass. So already we know that boron has 5 protons in the nucleus. So to find out how many neutrons, we subtract the atomic number from the mass number. So 11 minus 5 is 6. So the mass number always has to be a whole number, so we round it up or down. So the remainder 6 would be 6 neutrons. The number of protons is always equal to the number of electrons, so we have 5 electrons there. This gives us an electronically neutral atom. My next example is platinum. Atomic number is 78, so straight away we know that there are 78 protons and electrons. The mass number is 195, minus 78 is 117, so there are 117 neutrons in platinum. So now we're going to look at ions. So ions are basically elements that have lost or gained electrons, giving them a positive or negative charge. So for example, potassium, we know that there are 19 electrons according to its atomic number, but if we were to gain one more, it would give it a negative charge. And vice versa, if we were to gain 2, it would give it a 2 negative charge, etc. This happens due to an imbalance of the positive and negative charges of protons and electrons. So in a potassium element, there are 19 protons and electrons, making it neutral, but if it were to gain an electron, there is now one more negative charge, making the whole element negatively charged. If it were to lose an electron, it would become K positive. So an electron is lost, resulting in one less positive charge, making the whole element positively charged. So electronic configuration is how electrons are configured around the nucleus of an atom. This diagram here shows subshells S, P, and D, and F. Each circle area of this represents one orbital. Each orbital can hold 2 electrons of opposite spin. So S subshells can hold 1 orbital or 2 electrons, etc. And each shell is represented here as well according to colour. So this yellow colour is the first shell, orange is the second shell, etc. So now there is a certain order of how we fill these subshells according to the increase of energy that we can see up here on the y-axis. So we would start with 1s, then 2s, 2p, 3s, 3p, but instead of finishing off with the 3d, we'd fill the 4s first, as you can see, because it's at a lower energy than the 3d, and then we'd go on to then fill 3d, etc. So I'm just going to zoom in there a little bit. So we're first going to look at calcium, which has 12 electrons. So we fill s orbitals like this, one up, one down, representing 2 electrons in orbit of each other. Same for 2s, but then when we get to the p subshells, we fill them separately like this, just because it's less energy. They're filled singly before they're paired up. 3s would be the same. And so that would be our electronic configuration for calcium. So now we're going to do it for an iron. So we've got manganese with a 2 negative charge, so it's gained 2 electrons. So first we start at 1s, 2s, 2p, all the way up to 3s and 3p. Fill 3p the same as we did 2p. And then, as I mentioned before, instead of finishing in 3d, we're going to fill 4s first, and then the remainder of the electrons would go into 3d, like that. So this would be the electronic configuration, as shown there. And then the last one that I'm going to do was going to be iron. We're going to give it a 3 positive charge, so 3 electrons have been lost. So we've got 23 electrons to distribute. So we've got 1s, 2s, 2p, 3s, 3p, and vice versa. We're not gonna put them into 4s because we gain first there, but we also lose first there because of the energy. So the remainder would go in here into 3d. And that would be the electronic configuration for that.